Sometimes rational functions can be simplified by examining the common factors within the numerator and denominator. And my approach for teaching a lot of these is basically it's going to work in the exact same way as it would to simplify a normal fraction. So like thinking about the fraction, I don't know, let's choose something pretty easy like 4/6. We could reduce a fraction or simplify it or reduce it to lowest terms. Those are all kind of synonyms. But one of the ways we could think about this is, well, 4 is the same as 2 times 2. 6 is the same as 2 times 3. What we can tell by factorizing the numerator and the denominator is that 2 is a common factor. We could then cancel the common factor, which would leave me with the reduced fraction 2/3. And essentially, simplifying a rational function is exactly the same thing. Now, the thing I wanted to warn you about is that how I've seen a lot of students cancel rational functions is kind of like this. Like, okay, I have x on top and bottom, and I have x squared on top and bottom, so I'm just going to cancel them out like that. But don't do that. That does not work. That does not make sense. And let me try to, because the cancellation property for fractions only works when those are multiplied together, not when they are added. Let me show you exactly why that doesn't make sense. Let's say I had the fraction 4/6. I could write 4 as 1 plus 3, and I could write 6 as 1 plus 5. We don't do that because that does not help me simplify a fraction. That's why we're never taught to do this. But let's just say, well, okay, I'm going to cancel out the common 1 there. That would leave me with 3/5. 3/5 is not the same as 4/6. This is all totally garbage. And that's kind of why the equivalent fraction property is a property where if it has a common factor, the common factor could be removed because of, basically it relies on the fact that they're multiplied. So moving back to this case right here, those can't be canceled, so don't do that. You're never allowed to cancel in situations like this. You can only cancel them if you have first factored your number. So that's kind of what the step-by-step thing is for simplifying rational functions. Step 1, factor those rational functions, and step 2, cancel the common factors. So let's do that. Like looking at the first function f of x, now we could still find the domain and all those other things, but again, it's just a different skill. It's a different strategy for different purposes. The numerator has a common factor of 3, so I could factor that out. And the denominator is a difference of squares, so I could factor that as x plus 2 times x minus 2. And once I've factored the top and the bottom, I could say, well, is there a common factor? Here, the common factors are not just necessarily numbers, but entire polynomials. And since x plus 2 is a common factor, that would reduce this rational function to being 3 over x minus 2. The one catch here, though, is that even though this function simplifies, technically both plus and minus 2 were both not in the domain. Even though if I'm looking at this one, it might appear as though the domain is all real numbers except for just positive 2. Because the original function involved 2 undefined values, it still does. So the simplification, we should note that x can also not be equal to negative 2 as well in this function, because it would appear, algebraically speaking, as though it's fine. But it's really not, since it was created, like the original function was unsimplified. So technically there is a slight difference between these two, even though we will write that they're equal. And usually I'll kind of ignore that, and because it's something that's just implied based on it's just based on another problem. It's a situation. If this function were all by itself, being negative 2 would not be an issue. So let's look at another one. So step 1 is to let's look at g here and see if we can simplify. Step 1 is to factor each the numerator and the denominator. So the numerator is a perfect square trinomial, so that will factor as x plus 2 times x plus 2. And the denominator, again, I think I can factor this without doing a magic x. This should just be x minus 1 and x plus 2. But again, I'd advise, if you're not really sure, be very careful, because if you make any errors with your factoring, of course, it will screw up your simplification. But here I can see, once again, x plus 2 is a common factor. This would leave me with x plus 2 over x minus 1. Again, where 1 is not within the domain, but neither is negative 2 due to the original denominator.